All right, second part of 4.7 deals with composition of functions involving inverse trigonomic functions. It's a lot of functions in there in one statement. So you basically are going to have two parts. Okay? The first part is whenever you have sine function and its inverse, and the inverse properties. Okay? So whenever this happens, that means that you have either sine and inverse, or inverse sine, or inverse sine of sine. Remember, a composite is basically whenever we take one function and we plug it into another. Okay? Now, we can do that with sine, we can do it with cosine, we can do it with tangent. The biggest thing here is knowing what your interval can be for your x value. Okay, remember, like we talked about yesterday, there are certain stipulations as far as when we have certain things happening. Okay, whereas like whenever we have sine of a function, or sine of x rather, doesn't get, unless we move it, okay, or we stretch it, or we make the amplitude different, things like that, unless we manipulate it somehow, it goes from -1 to +1. Whereas yesterday, whenever we talked about our inverse of sine, it only goes from -π/2 to π/2. Okay, so whenever we think about, remember, sine is always my y value, right? Okay, so if it's my y value, a lot of what we'll do is we'll think about this in terms of like our unit circle, where whenever we have sine, yesterday, or like normally whenever we had a circle, it goes from -1 to +1, right? Okay, that's our values. Whereas yesterday, what happened? Okay, whenever we did this yesterday, we cut our circle in half and basically said that our circle can only go on this right side. And the left side really doesn't exist. Right? So it only goes from π/2 to -π/2. Okay? Where our x values flipped. Okay? Whenever we went from our inverse, or from our function, from our angle rather. Whereas with cosine still for a regular trig function only gets as high as +1 and as low as -1. Okay, whenever we actually graphed it. But then when we talked about the angle with cosine, what did we do? How did we cut our circle in half yesterday? Top and bottom, right? And the bottom didn't exist. Okay, we only looked at everything from the top half instead of the right half. We looked at the top half. Then whenever we were doing tangent, okay, tangent can be any number. We can go with any value and have a value for tangent, because we can always multiply, we can always divide, we can always have y over x or x over y, positive or negative, it doesn't matter. We can, as long as we didn't have a 0 on the bottom side, everything was good. Okay? But for every real number, we can plug in for x, or we can have. Okay, so there are no restrictions here. But if we flip it around and we go inverse tangent of x, then we have to be within the interval of -π/2 and π/2. Okay, it goes back to the same interval, or the similar interval that we had yesterday with sine. The biggest difference here is π/2 and -π/2 are not included. Okay. You know what pi is equal to, as far as if they just give you some random number. Okay? If they give you some random number, you know that pi is about 3.14. Okay? The one thing that you probably do need to know is that pi over 2 is about 1.57, somewhere in there. So depending on what value kind of gets plugged in, okay, it may or may not work. Okay? All of it depends on the order. Okay? All of it depends on the order in which, like with any of these three, everything's going to be in terms of radians. Okay? All of these are, I can't write it. If it's in this order, we're going to be dealing with radians. So if inverse sine comes first, it's most likely going to be written with, it's not always going to be the case, but there's probably going to be a pi somewhere. Again, not guaranteed, but that's kind of your pi over 2 to negative pi over 2. You're going to probably be dealing in something with pi. Okay, so kind of know that going in. Whereas the other three, those are going to be more of your like regular numerical values. Okay. Again, big disclaimer up right at the top. Then you can only use the above properties if x is in the specified interval. If not, then we'll have to do more steps. We'll do that later. But then we'll worry about that whenever the time comes. Okay? So the first one says, so it says find the exact value if possible. First one says cosine of inverse cosine of 0.6. First off, does the 0.6 fit? Its cosine is out in front. So what's my interval if cosine, not inverse cosine, but cosine is out in front? Where does my interval have to fall? Between 1 and negative 1, right? So does 0.6 fall within my interval? Yeah, everything's good. So then what's going to happen to the cosine and the inverse cosine? What are we going to do with them? Say it louder, Audrey. Cancel them. So then what are we left with? 0.6. Now on B, it went from its inverse sine of 3 pi over 2. So like we said earlier, that if it's inverse sine, those are usually going to be written in terms of radians. Okay, on the inside. Is 3 pi over 2 within my interval? What is my, or let's go this route. What is the interval for the sine function if it's inverse sine? Where does it go from? Negative pi over 2 to pi over 2. Is 3 pi over 2 within that interval? Have some people shaking their head no? Do I have anybody saying yes? No? So you're going to say it doesn't work? Yesterday we did this right here, right? We said that sine goes from pi over 2 to negative pi over 2. Where's negative pi over 2 at? Huh? Well, that's just a numerical value. Huh? Well, there's 1 pi over 2, there's pi, there's 3 pi over 2. So aren't those two the same thing? Okay. So is this one within my interval? Yeah. Okay. 3 pi over 2 is just going in a positive direction. I went through the forest over there on the left side that I'm not supposed to go through. I can't really, and then I come out the other side and everything's okay. Okay, instead of going through the green part on the left side, I really should have just peeled back and went through the the bottom side, and I still end up in the same spot. Okay? So if you have 3 pi over 2, or anything in that fourth quadrant down there on that bottom side, that's okay. All right? It may be written as something different, but remember, I can go in a negative direction just as well as I can go in a positive direction and still end up in the same spot. So everything's good there. So then what is inverse sine of 3 pi over 2? What's going to happen? Yeah, it's just 3 pi over 2. Now on C, where I have cosine of inverse cosine of 1.5. Cosine's first, so it's not really looking at my radians, so I'm not dealing with either pi over, or 0 to pi, or negative pi over 2 to pi over 2. What am I looking at? What's my interval for cosine? From where to where? Negative 1 to 1. So, cosine of inverse cosine of 1.5 is just going to be what? 1.5? Huh? Yeah, you're good with that? Why not? It's outside the interval, right? Okay. So, 1.5 is outside the interval, or outside the restricted area. Okay, can't get outside the restricted area. That's bad. That's bad news. Okay, bad things happen outside the restricted area. Okay, so it's just going to be no solution or undefined. Last part deals with evaluating a composite, not a compound, a composite trig function. Basically what's going to happen here is you are going to have two different types. It's not like you're going to have sine and inverse sine, or inverse sine and sine, or cosine and inverse cosine, or tangent and inverse tangent, stuff like that. Whenever we're evaluating here, you're going to have two different types of functions. Most of the time, what you're doing is you're trying to figure out, you're going back to your trig functions of like your opposite over adjacent, your adjacent over hypotenuse, opposite over hypotenuse, that sort of thing there. Now, remember that whenever we do this, we're really just making a triangle. Okay? So whenever we do this, one thing that I would just make sure that you remember is a few of your trig ratios. Remember that whenever we have sine, sine is the same thing as opposite over hypotenuse, but it's also going to be y over r. Okay? If it's like the radius of our circle, okay, the y is always our our sine is always our y value. Cosine, normally we call it adjacent over hypotenuse, but whenever we're dealing with coordinates, we would usually go with x over r. And then tangent would be just opposite over adjacent, or sine over cosine, or y over x. Then for our other three of cosecant, secant, and cotangent, what did we do with our originals? We just flipped them, right? So cosecant, I'm just going to write as r over x, y, wrong one. Secant is going to be r over x, and then cotangent is x over y. All you're doing here is basically taking two parts. You're trying to figure out, one, where is it at? Okay, what area is it in? And it's going to be the areas that we talked about yesterday, either the top half or the right half. Okay, if we think about like our circle. So the one place that everything does not exist is down here in the restricted forest. Okay? Where can everything always be? So we can't go down in quadrant 3. Can't do it. Okay? Not going in there. Where can everything be though? Where's the one place that sine, cosine, and tangent can all be? Quadrant 1. Okay? Everything here in quadrant 1, we're good to go. Okay, so everything in quadrant 1, we're good. Okay, I can have inverse sine, I can have inverse cosine, I can have inverse tangent. Whenever we talk about what is positive in quadrant 1, what's positive in quadrant 1? Sine, cosine, tangent, 1, 2, what? All of them, right? Okay, so everything from sine, from cosine, and tangent are going to end up positive. Okay, as far as whenever my finished product. Normally what's going to happen here is you are going to get your angle or your inverse of sine, cosine, tangent, whatever, on the inside, and then you're going to be taken to a trig function on the outside. Okay, you're trying to figure out first what the angle is, and then how's that going to replicate what our actual trig function or trig ratio is. So then we've got the other two parts that are that's in quadrant 2 and quadrant 4. Over here in quadrant 2, let's make it blue. 2 and blue, that sounds good. What can happen in quadrant 2? Which of my inverse functions can be in quadrant 2? Sine, cosine, or tangent? Oh, we've got discrepancy. That's good. Remember, what did we do yesterday? Yesterday, whenever we were looking, whenever we chopped it in half this direction, this way, what was on the upper half? Cosine, right? So I can have inverse cosine can be over here. Now as far as my regular trig functions, what's positive in quadrant 2? Sine will be positive. Okay, it will be a positive value. Okay. Notice that whenever we're doing this, we're dealing with our inverse of our function, and then we're dealing with just our regular trig function. Then the last one we have down here in 3 what inverse functions can be down here? Okay, down in quadrant 3, or excuse me, 4. What am I doing? There we go. Down in quadrant 4, what inverse functions can be on that right side of my graph? Sine and tangent. Okay, so I can have inverse sine down here, and I can have inverse tangent down here. What is always going to be positive in quadrant 4? Cosine. So with what I have, the one thing that can never be positive, inverse tangent can be positive if it's in quadrant 1. The only time whenever we deal with tangent being positive is this thing, this part of the triangle, or this coordinate better be in quadrant 1 because it can't be down in 3. Because that's like it doesn't even exist. Okay, we can't go down in that green area. So what we've got to do is we've got to figure out where everything is. Okay, we're essentially trying to find whatever our angle measurement is. Okay, whatever theta is. So in doing that, if we have inverse tangent of 5 over 12, well, what does the 5 represent? Does it represent the x, the r, or the y? The y. What does the 12 represent? The x. What else do we need? Okay. We need the r value or our hypotenuse. You can either write it that way or x squared plus y squared equals h squared, whatever you want to call it. It's all the same. But the first thing before I do anything is I need to find whatever my missing part is. Okay, because most likely I'm going to need that before I do anything. So if I have x and I have y, that means I have 12 squared plus 5 squared equals r squared. Remember, the r is just the radius of my circle. It's like if I had a point at 12, 5, and I drew a circle from the center. Okay? I would need to know what my radius of my circle is. So then I have 144 plus 25 equals r squared. So 169 equals r squared, so r is equal to 13. How do I write my trig function, or how do I write the value of cosine of theta? Cosine of theta is just whatever inverse tangent of 5 over 12 is. I don't need to use a calculator. I don't want to use a calculator. How do I write cosine? It's adjacent over hypotenuse, or it is x over r. So what is cosine of theta? Remember, that is just my x over r, which is what? What's my x value? What's my r value? 12 over 13. Okay, what I'm doing here is I have some point over here at 12,5. I'm essentially just making a triangle. That's 5. That was 12. There was 13. Okay. I'm trying to figure out what the angle there is. Okay. If it's cosine, it's just going to be whatever 12 over 13 is. I'm using one trig function to find another. Okay, and find the value. On 9, it says find the exact value of cotangent of inverse sine of negative 1/3. I have a negative. Negative has to belong to one of those numbers. Okay? If negative has to belong to one of those numbers, and I'm dealing with sine, I'm going to go over to the right. Sine is opposite over hypotenuse, or y over r. What is the one value that cannot be negative? Can my x value be negative? Yeah. Can my y value be negative? Can the distance from the center to that point be negative? No, so r can never be negative. So basically what I want to do is I want to rewrite this as negative 1 over a positive 3, because if it is sine, there's my y value, there's my r value. R can never be negative. So the negative is going to belong to my y or my x value every single time. It's whenever I have a negative with tangent that's where I've got to kind of pay attention to what I'm dealing with. Okay? But everything else, if it's sine or cosine and an inverse of that, then it should be pretty easy. Okay? And the good thing is, if we know that, if we know where tangent is, everything else kind of fits into play. So then, if I have y and I have r, which other variable do I need? X. So remember that x squared plus y squared is equal to r squared. So I don't know what x squared is, but bless you, I know that y squared is negative 1 squared, and r squared is 3 squared. So I have x squared plus 1 equals 9. X squared equals 8. So x is equal to 2 times the square root of 2. Sorry about ran out of room. Now, this one's a little bit different. So I know that that's not going to be negative, but I have cotangent. Cotangent is just what? If tangent is y over x, what's cotangent? X over y. Well, what's x? 2 square root of 2. What's y? Negative 1. So what is cotangent of theta? Negative 2 times the square root of 2.